in essence, you can basically, you don't need a landing strip. You don't need a takeoff place. You don't need anything like that. You can literally take this thing off from the driveway if it works correctly. Because again, if it's only a micrometer at a time, you're not doing anything. So you can literally launch from your driveway, go and grab Elon Musk's car that he dumped in orbit, slap a parking ticket on it, obviously, put it in his driveway, go home. Total time is 10 seconds. Most of that's docking with the car. That's nothing. We can go to Mars in 8 minutes if we're doing 1/3 the speed of light. As we get bigger warp bubbles, now we're learning more about the geometry because, good example is James Watt steam engine. It worked. It was inefficient as hell, and it got the job done, right? But several iterations down the road, now you can build a much cheaper steam engine, a much better steam engine, and so on and so forth, right? And we're thinking the same thing's going to happen with this. The more people who work on these things, the better chance they have of actually figuring out weird, wonky stuff that will actually produce more things. That's where we're building kind of a hub and spoke model. The spokes are all 6, 8, 10 labs are all doing their own thing. We have a central hub in Atlanta that we're going to be building that we do verification studies. And for phase 2, when we actually do proof of concept, now we're actually working on fusion research and building fusion reactors. By that point, we've actually got like the best lab in the world for warp field stuff, which means that, yeah, we can contract all this stuff out, but they still come to us for that stuff, and they still come to us for verification and whatnot. And we're going to have a lot of staffers on board who are kind of, like I said, with IBM and Bell, one of the big things they did was take 20% of your time, go mess around the lab, go play, go do whatever you want. Weird shit comes out of that, and some of that weird shit might be useful to us in this concept because you're trying to go this way. And my go-to example is Alexander Fleming with penicillin. He was a slob. In this case, that was very good. Charles Goodyear, he was a klutz. He knocked over rubber and sulfur, and now we have vulcanized rubber. Like, there's plenty of examples of just really screw ups in the lab. Oh God, the bird shit in radio transmitters led to figuring out background radiation, right? So like, there's all kinds of like, crazy stories, and I want to make sure that the people that we work with take that time and energy to kind of go, let's go down this random road. What the hell does this lead us? I mean, don't get me wrong, half of it or 75% of it's going to be, kind of crap, but that's science too. Like, it's not about we're going to find this answers. Well, we found 200 ways we can't do it, and that's okay. Now, the thing is, we don't really know if it's going to work at all. It might be beyond our technological capacity as of right now. It might be. We don't know yet. We do know that this didn't run on coal, right? We do know that this didn't have an oil reactor in there. Matter and antimatter would be lovely, but we as a civilization do not have the ability to produce appreciable amounts of antimatter to get the job done. But with enough fusion reactors, and if the field's plentiful enough, then you're good to go. Oh, and also the fusion reactor is about that big or so. And that's going to produce about a terawatt. Even better, I did not say fresh water. So once you get it up and running, you can literally just stick a nice little tube in the ocean and pull that out. Dump the salt off somewhere. That also kind of helps the water crisis because there's plenty of energy coming from the fusion reactor. So now I can kind of take that and start producing fresh water from it. This can move us to Kardashev 1. And it is something that is, I'm really lucky to be alive right now, because if it was 2 centuries ago, I'm sure I'd been, burned at the stake for being a witch or something like that. But it's kind of an extraordinary time, because now all of a sudden, because these theoretical physicists have been pioneers in doing the math, now we know it's possible. But a lot of them were very thinking like, I want to build the enterprise. I want to build the enterprise. And no one thought about how to get there. So